Today we're going to look at solving multi-step linear equations. Now we've solved two-step linear equations in the past. One of the things that I encouraged you to do, though I didn't require it, is to put a little very light dashed line down through your equal signs to make sure you leave them lined up from start to finish. Now, we will run into some situations here where that first part of solving linear equations is going to come into play, and that is if we just kind of cover up one side of the equation and look at the other side. I'm looking to see if there's any distributive property to do, and there isn't, or any like terms I can combine, and there aren't because this is an x term and this is a constant. Same thing on the right side. There's no distributive property, and these are not like terms that I can combine, but that will come into play in future problems today. So, I would like to eventually get my variable term on the left. I'd like this to be x equals something when I'm done. Because I have both variables and constants on both sides of the equation, I'm going to choose to move my variable to the left. So I don't want this minus 2x on the right side of the equation. The way I'm going to undo a minus 2x is to add 2x. Now the addition property of equality says I can do that and keep this equation in balance as long as I also add 2x to the left side of the equation. So I end up with 7x minus 8 equals 4. Now I don't want this minus 8 constant on the left, so I'm going to add 8 to both sides of the equation. Again, the plus 8 undoes the minus 8. It eliminates the constant on the left side of the equation. And I'm left with 7x equals positive 12. Now that I'm down to a single variable term equals a single constant, to undo this multiplication between the 7 and the x, I would divide both sides by 7. Now, if you put this in your calculator, you're going to get a repeating, or you're going to get a decimal that fills up the entire screen, which means you are not allowed to give me your answer as a decimal. It has to be a reduced, in this case, mixed number because 12 is larger than 7. So, by the time I convert it, it's 1 5/7 for my answer. Now, to check this in my calculator, I would need to do 5 times 1 5/7 minus 8 equals, and then 4 minus 2 times 1 5/7 equals, and make sure both sides of the equation really do equal each other so that 1 5/7 is my answer. Now here we have a problem that's very similar in that if I look at just the left side of the equation, I just have a variable term, a constant and a variable term, no distributive property, no like terms, and the same thing on the left. I just have a constant and a variable term. So I eventually want to have my variable term on the left, and if I want to have my variable term on the left, it makes sense to eliminate the variable term on the right. So to eliminate a minus 10x, I would add 10x to both sides. Make sure I'm adding 10x, not just 10. Notice I'm lining my like terms up on each side. So I end up with 6 plus 14x equals 8. Now I don't want my constant on the left since it's a positive 6. I would subtract 6 from both sides to eliminate the constant on the left side. And I end up with positive 14x because of the plus in front of it equals positive 2. 8 minus 6 in your calculator, or 8 plus negative 6. Either one will work. Now, single variable term equals single constant. To undo this multiplication between the 14 and the x, I would have to divide by 14. And again, if I punch 2 divided by 14 in my calculator, I get a decimal that fills the entire screen. So instead of giving a decimal, I need to just reduce this fraction. 2 over 14 reduces to 1 over 7. This is the first problem where if I just cover up one side of the equation, all of a sudden I have something I can do to simplify this on the left side before I solve the equation. So the first thing I want to do is the distributive property. I need to take 2 times 3x and positive 2 times a positive, because of the plus in front of it, 5. So 2 times 3x is 6x. Positive 2 times positive 5 is positive 10, so I write plus 10. I can't combine these because they're not like terms. Now, looking at the right side of the equation, There's nothing I can do to simplify that because negative 14 is just a single number, so there's nothing else I can do. At this point, this becomes a two-step linear equation. I don't want the variable and constant on the same side. Since there's a constant on the right, I want to eliminate the constant here on the left. To eliminate a plus 10, I'm going to subtract 10. Again, the subtraction property of equality says I can do that as long as I do the same thing to the other side of the equation. So I end up with 6x equals negative 24. I would punch this in my calculator as negative 14 minus 10, or negative 14 plus a negative 10. Divide both sides by 6, in this case to isolate the variable, so x equals negative 4. Now to check this in my calculator, I would need to punch in 2, and some calculators make you put the times, most don't, and then 3 times negative 4 plus 5, and then equals, and make sure it really does equal the negative 14 on the other side. Now the last problem we're going to look at, if I look at the right side of the equation, it's just a single number, negative 8, and I can't simplify that. But if I look at the left side of the equation as its own simplification problem, I notice that, first of all, I have distributive property that I can do. So I'm going to distribute a negative, because of the minus in front of it, 8, to x, and a negative 8 to a negative 1 because of the minus in front of it. The 4x I'm not doing anything with at this point, so it just gets written down in my next step. Negative 8 times a positive 1x is a negative 8x. Instead of writing plus a negative 8x, I'm going to write minus 8x. Negative 8 times a negative 1 is a positive 8, so I write plus 8. Oops. Plus 8. Now, I still have, looking at that side of the equation as its own simplification problem, I still have a 4x minus 8x on the same side of the equation. 4x minus 8x is a negative 4x, and I'll bring down this plus 8. Now, nothing has changed on the right side of the equation. It's just still negative 8. So I can copy that down, negative 8, and bring it down in the next step. At this point, this is a two-step equation. I don't want the variable and the constant both on the left. Since there's a constant on the right, I want to eliminate this constant on the left. To eliminate a plus 8, I'd just subtract 8. And I'd subtract 8 from the other side of the equation. So I'm left with negative 4x equals negative 16. And then the last step, undo this multiplication with division, so x equals positive 4. In my calculator to check this, 4 times, and let me put this down, 4 times positive 4 minus 8 times, in parentheses, 4 minus 1 equals, and make sure it equals negative 8. Thank you.